afternoon, all of you. I am AMISHA BHARTI, and my today's presentation topic is GETIS-ORD GIS star-based farmer suicidal hotspot detection. And my co-supervisor is Sona Jaria Minj. And today presentation I will talk about introduction, data description, methodology which I have used for hotspot detection, and then after farm experimental section, followed with conclusion and at last reference. First, introduction. We all know that farmer suicide is a green issue for our society and has followed an increasing growth rate trending over the last 20 years. For farmer computing hotspot, we have considered four factors, that are the what number of farmer suicide in state-wise, what are the population density of that state, and what are the environmental factor, and last economical stress which farmer are facing. Now for the data collection, the farmer suicide data which are collected from the National Crime Bureau Record Bureau NCBR for the agriculture in year 2004 to 20, and for the population density and total population we have collected data from census commissioner, and environmental data I have collected from meteorological department, and agriculture plants is the source of all the farmer incomes, loans, and farming expenditures. Here I have used this methodology. First, what number of farmers suicided, how can we find the hotspot for the state-wise region. Factor for the analysis, I have used number of farmer suicide, population density of the state, climate factor like rainfall, drought, and flood, and then economical stress what farmer are facing like income, loan, and agriculture expenditure. For the clustering analysis, we have used a spatial autocorrelation, cluster outlier analysis, incremental autocorrelation, and last one is the GETIS-ORD statistics, where you also use the nearest neighbor analysis for the point density map. For this, we have find the output, and where we get Z-score. Z-score decide the which zone are vulnerable zone are farmer suicide. If that is the positive, that the hotspot, and negative, that the cold spot. Now the first technique I have used average nearest neighbor analysis. We have used average nearest neighbor analysis where Euclidean distance to find the nearest neighbor distance analysis. This tool is measured the distance between the centroid of one feature to the centroid of other features location, which is used to predict the nearest neighbor index. And the average nearest neighbor ratio is calculated with the ratio of expected mean value upon observed mean value. Now the Moran I for the spatial autocorrelation, global Moran I statistics has been used to measure the spatial autocorrelation, in which there are the three classification statistics which appeared as a positive, negative, and not correlated. Positive and negative autocorrelation show the respective similarity and dissimilarity a value cluster in a map, and the value of Moran I index range between +1 to -1, which a positive value input toward the clustering and negative value toward the dispersion. Now the method is the GETIS-ORD based for hotspot detection, which defines a hotspot is defined as a region that has a greater concentration of incident as compared to expected number of random distribution. Hotspot generated Z score and p value. A significant hotspot is indicated by a high Z score and low p value, which a negative and low Z score indicate a significant cold spot. The result express high Z score and low p value of computed GIS star, which represent the statistical significance of a spatial cluster, and also used to detect the vulnerable and non-vulnerable area as a hotspot and cold spot. For the experimental, we have used ARC GIS for the mapping, and here we have find the result for the farmer suicide, population density, environmental factor, in economical factor, to the corresponding with the Moran I expected index, Z score, and p value. Here this shows the clustering, randomness, and dispersion. This is the average nearest neighbor graph. After the hotspot detection, applying all the techniques, we found that the Maharashtra, this region, Tamil Nadu, and Andhra Pradesh are the highest number of farmer suicide. For the further analysis, I have used Maharashtra as a what number of farmer suicide in which region has the more farmers committed suicide. This is the red region shows the maximum number of farmer suicide, and the orange region it is the less than the red zone, and minimum are the blue zone. And in this last one here we show the number of farmer committed suicide, that is the blue line, and red one is the how any person which are related to the farming sector that are that committed suicide, that all the both when we add both the suicide number, that is the very huge every year. This amount of farmers or agriculture related persons committed suicide. Now the conclusion is that we have used the spatial analysis techniques to help the address the average nearest neighbor and Moran I as a analysis global pattern, and the computed value of the farmer suicide has mentioned a clustered pattern for the geographical map representation of farmer suicide hotspot using GI star technique. The result represent the highest number of farmer committed suicide index in the Maharashtra, and a small and marginal farmer are more to risk to suicide and due to loss of farming sunk cost. A farmer suicide hotspot detect with the help of reduce the risk of farmer suicide with the help of new initiative in agriculture techniques, and these are the references. And thank you, thank you.
Thank you, ma'am. That was a very good presentation.